Hello everyone and welcome to our webinar session in regard to Smart Air Injection, short SAI, for an efficient spent grain transportation. So my name is Stefan Mödle. I'm Global Product Manager for Smart Air Injection. In this function, I would like to present to you today this topic, which is SAI for efficient spent grain transportation. So how could you substantially reduce your total cost of ownership by minimizing your total air emission? First, let's come to the content of this webinar session. I will start with a short motivation. So why is conveyance of dewatered spent grain so interesting? Then I would like to explain a bit the SAI conveying concept and the SAI control logs. And then I would switch over to the practical part where I explain a bit about our reference installations and some validation studies that we have drawn in Germany and also in UK. And last but not least, I would summarize the benefits of our system. Motivation. So why is spent grain transportation so interesting? Because it occurs in many of the industries. So we see it in brewing industry, also for the malt vinegar production, and also in the distilling industry, that spent grains are produced and that it's a byproduct for you in your industry, because you would best get quickly rid of this product because it's once processed and then it's for you not so interesting because it goes further into animal feed, so for animal feed production, or also for the renewable energy industry for the production of biofuels. And all in these steps, spent grains, which is highly abrasive and also viscous, has to be conveyed. And that's here the question we are dealing with. How is this spent grain transportation done very efficiently? A further motivation comes from the industry of brewing and distillery. We see increasing requirements on process efficiency in these industries. So especially total cost of ownership considerations get more common, and also the consideration of energy efficiency of all your processing equipment is quite common to be considered. And since the building density in most of the older and historical breweries, distilleries is rather high, more often when they would like to expand and increase their productivity, the longer transportation distances are quite common to occur, of 100 meters and even more. And another point is process reliability, especially when you have slight changes in your processing, different wetness content, in order to ensure that you stay with your productivity is quite important. And our answer to this is smart air injection. So if you see it here in a example brewing process, after your lauter tun or mesh tun or mesh filter, when the spent grain is processed, we apply here a combination solution which is called SAI, and which combines two known technologies, which is a progressive cavity pump, that's our bread and butter skill, and that is combined with a way of pneumatic conveying, which is called dense phase conveying. In order to see the benefits of SAI, I would like to compare it to conventional solutions of pneumatic conveying, which are pneumatic expeller units like a Pondorf or Wette unit. And the challenge on conveying these spent grains is that it's highly abrasive and that it's also highly viscous, and so could not very easily be conveyed by a pump over a certain distance. And the common way of doing this is here by a pneumatic way of conveying it. First with a screw conveyor, so the spent grains falls here from the mesh tun, mesh filter into the screw conveyor. It's conveyed into the discharge pipe, and then you use here a type of lean phase conveying where this granular media of spent grain is blown with constant flow of compressed air through your system and thereby conveyed onto your destination. And what you require here is a very high velocity of compressed air that is going through a system, and you need it constantly because it's an uncontrolled flow here of compressed air, and therefore you need a very large compressor that are quite common. So usually also for mid-range or larger breweries, we see here compressors in the range of 100 kilowatt installed motor power, even more. And this is because you cannot buffer the compressed air in the way here to the conveying, and you need it constantly all the time. So the compressor is running nearly all the time when you would like to convey your spent grains down the line. In contrast to this, we see here on the bottom the smart air injection system, and it looks quite similar because you have also here air line where air is supplied to your system, and you have on the bottom here the spent grain transportation line. And also here you have an extension hopper where the spent grain falls from your mesh tun and mesh filter into. And you have here inside our pump a screw conveyor that is in a first step conveying the spent grain into our pump element. And this progressive cavity pump element is the main difference between a pond-off system and a smart air injection system, because we can thereby overcome a certain pressure level inside the pipework and can use the usual way of pumping in order to generate here 30 or 35 meter of plugs inside the pipework that are quite stable and only done by pumping. And we then use the pneumatics to further convey this down the line like a pneumatic post system. So once those plugs are generated of spent grain by our pumping, and then by a purposeful and short-term air injection, we once accelerate those plugs and shoot them down the line. And that helps us because we do not need constantly air and only on very short instances and very infrequently, that we minimize our air consumption, and that we also get the ability to buffer the compressed air that is used. Because we have here between two injections time intervals of roughly 5 minutes, and that leads or is able a small compressor unit here of 10 kilowatt installed motor power to achieve here enough normal cubic meter of compressed air that is buffered in a buffer storage and then used here every 5 minutes to do the dense phase convey down the line. What is the benefit by this system that you receive? We could highly significantly reduce your total cost of ownership, especially in regard to energy costs for air. What we have achieved here in different validation studies is a reduction up to 80% in air consumption, and that goes directly with your energy costs that you are required here for energy. We can increase the process efficiency because we reduce your mash out times. In some of the applications we could reduce here from 55 minutes down to 22 minutes by exchanging the screw conveyor of a expeller unit with a progressive cavity pump, because it's rather a constant independence on the different operation points. So if you have varying moisture content in your spent grains, the pump is independently running constantly the same if you have different moisture content, and the spent grain is further conveyed by dense phase conveying. If you have a stable plug here of medium, it's independent of the moisture content and it's always running the same, which makes this system quite stable. We enable here a flexible piping, multiple bends is not an issue, and also vertical transportation of 30 meters and even more. And we enable here a transportation distance maximum up to 1 kilometer of distance, because we use here a type of dense phase conveying. Another benefit that we bring to the customer, that is we reduce the wear sensitivity of your pipework. Because what we have known from other larger breweries is that they often with a pond-off system have to replace every 3 to 4 years their entire pipework, because especially in the bends they have high significant wear occurring on the bend material and they are broken and done and they have to replace the entire pipework. But the benefit that we have with this dense phase conveying of SEI is that we bring down the velocity of this conveying type down to 3 to 5 meter per second instead of 30 meter per second for this lean phase conveying of a pond-off system. And that goes directly with the wear sensitivity of your system, and the system we have set up with SEI have till now never been changed by pipework. Come now to the conveying concept and also the SEI controller logics and the condition monitoring. So if I tell you now a pneumatic system is very, very efficient, you are maybe struggling a bit. That's also my first impression, because I know from my studies at university that a compressor is rather bad in efficiency. Nearly 90% of its efficiency goes to heat instead of compressing the air. But it could be efficient if you use it very purposeful. And if you compare different types of pneumatic conveying, this lean phase conveying is here really that you need all the time constantly air, and you blow with very high velocity at a lower pressure this granular media through your pipework. So that's from the ratio, the air amount that you have to use and consume to convey a certain line loading of a medium is rather bad. We have in between this intermediate phase conveying, which is also quite bad. You have a swimming bed of medium on the bottom of your pipework. It occurs here at medium velocities of 15 meters per second, but also here the air consumption is rather high compared to the line loading and to the conveyed medium. And the only way how a pneumatic way of conveying could be efficient is when you use it here in type of dense phase conveying and when you enable very long plug medium. So 30 meters and even more will be achieved only by pumping, and then very short time and infrequently you need then purposeful air injections to one, accelerate those plugs and push them down the line. And that is here on rather low velocities because you only have 3 to 5 meters per second compared to 30 meters per second. And that enables also to reduce highly your pipe wear sensitivity. Another effect that we make use of is the shear thinning rheology of the fluid. So both the mesh and also the spent grain is highly shear thinning. Let's hear from measurement results that we have from paper of spent grain that was here rheologically measured. And what you see here is that the viscosity for shear thinning fluid is reduced by higher shear. So like the name is telling you, under a high shear, the fluid gets thinner. And that's perfectly for us and we can make use of it. So the high shear rates occur in a pipework where you have the high velocity gradients. And in this example here, you see in the very boundary layer region of your pipework, that's the region where you have this rather high shear rates. And if you have then very high velocities, so there are models how you can describe this behavior of the fluid, but the important point is this here, that the pipe shear rate goes proportional to the velocity of your system. And that's why also pumping of spent grains is rather hard, because it's occurring on relatively low velocities, and that means also you are here in a region where the viscosity and the pressure losses inside your pipework are rather high. But if you compare it now to smart air injection, due to the fact that we have these plugs and do the further conveying on a high velocity, because we once accelerate those plugs and shoot it down the line, we are in this region where the shear rates are highly increasing. And it's increasing locally in this boundary layer close to the wall of your pipework. And that's where we have reduced viscosity and we make the fluid thinner in a range of a factor 5. And that's perfectly for us because we're shooting these plugs down the line and they're fluidized around the circumference of this plug or fluid and make it easier to convey. To explain this behavior, a good children experiment is ketchup, because ketchup is perfectly shear thinning, and if you put a golf ball on top of your bowl with ketchup, it sticks on top of this layer because it's highly viscous. But if you let the golf ball fall from a certain distance into the bowl here of ketchup, it's fluidizing the ketchup because the shear rate is highly increased on impact of this golf ball onto the ketchup fluid. And that's really here the effect that we also use for smart air injection. Let's see how the process looks like in the end. So that's here really a measurement signal that we've drawn in a southern German brewery. And you see here the signal is rather constant. And after its injection, we have received here nearly zero pressure inside our pipework. And then only the pump is working and is conveying this plug of material into the discharge pipework. And remember, this is here 20 to 30 meters, this plug that we have achieved. And then we reach a certain pressure level, which is ranging here around 3.5–4 bar. And we open up the solenoid valve and once accelerate those plugs of medium, we have a small peak here in the pressure, like a pressure spike, for once overcoming the frictional losses of this plug. And if it's once accelerated through the pipework, the pressure is directly decreasing until we reach here our destination in the bottom of the silo, and the process restarts again and we have received here zero pressure again. So let's summarize. Why is this system so efficient? It's by two effects that we make use of. First, we make use of this pneumatic dense phase conveying, so a way of discontinuously convey the spent grain through the system, so we need only very short air injections, and it's even easier for us to convey it down the line because we make use of the shear thinning rheology of the spent grain medium, and that leads in the end to very short-term and infrequent air injections, and to the case that we can apply a system of SEI for a large amount of spent grains with only 10 kilowatt per hour, 10 kilowatt of installed motor power. The system comes as a package unit, and that means that all the machines, so like compressors, air receivers, and the pumps, come along with sensors and actuators that are all these functional components integrated into a control logic which is called SEI controller. You see here a certain visualization of the process. You get access to all the control parameters, and the system controls itself in regard to flow rates and the air injections, and we ensure here that all safety functionalities are safe. And you have an overview about all your consumables like air and also energy, so you have an overview about your operational expenses that you have by the conveying process. And you have only one interface to your superior control system, so by all common field bus signals you get out here and into your control system. Another way that we have since the beginning of this year is that we have pre-compiled modular code components where the SEI logic is pre-compiled, and you can put it to your PLC, your Siemens PLC, if it's already in use, and we can upgrade your own control logics by our SEI controller with a short visualization in HMI. You can then get access very flexible and upgrade your PLC and control system by our SEI logics. If you need another safety and reliability on your system, we have the possibility to upgrade our SEI controller with the connected services. And that means that you upgrade it by an IoT gateway or a pump monitoring system that enables you first to get access here by Bluetooth, by your mobile phone, so that you can always, on all of your plant components, get access to the status, the maintenance, and also the protection status of your SEI equipment. If you have any warning set up or error signals, then you get it at home and are warned in advance and early enough to react on any issues that might occur on such a system. And if you have also different locations and multiple pumps set up with the pump monitoring, you can bring all the pumps together in the SEEPEX connected services. So that's a cloud service where you get access via a web interface, and you get here in this web interface an overview about all your pumps, how they run at the moment, what about the status, do they require any maintenance in short term. You can click on every pump and see the current status, the historical data, the trends of the operation on these signals. And you also have the possibility by advanced analytics to compare the current running scenario with the characteristic curve of your pump, which gives you also the ability to have a wear indication, so the system can warn you in advance when the wear status is increasing, and when you need a maintenance or a service cycle where some of the wear components are replaced. And also anomalies could be detected in advance when there is an irregular operation of the systems. Every month you receive then a report in the end, which is telling you about the current status of performance of your maintenance components in the pump and about the protection which is ensured here. And if you also set up this system over the entire process, we have also the ability here to monitor some of your process functionalities. So in the end, you have here the full remote access to your running equipment and a permanent data storage, and you can run also some targeted analysis and optimizations on the operation of your SEI systems. That helps you to reduce the downtime and reduce your operational expenses more by the system, and to optimize the operation point of all pump equipment. Let's go to the practical part and some references where initially also some years ago we have replaced some of the existing expeller units by similar to smart air injection systems, where also a passive cavity pump is replaced instead of these screw conveyors. And there are two validation studies where full SEI systems are run and compared to conventional systems. We have done here, beginning of the year, live demonstration in a southern German brewery, which was quite large, and where they have here a mash filter where the spent grain is dewatered to a moisture content of around 78%. And that goes here to this extension hopper, where it's by the screw conveyor made into our pump. And that's here the element where we have replaced the pre-existing screw conveyor of a pond door system. The piping is 50 meters of distance and 20 meter vertical elevation, and the grain capacity is in the range of 14 tons per hour. And what you see is after this grain distance, the and then the process restarts again, and the pump starts to convey the next 30-meter plug into the pipework, and we restart to inject air in the end. So that's this batch operation of conveying pneumatics in dense phase. What we're able here is a reduction of air consumption of 80%. So we've achieved here for conveyance of 4 tons per hour of medium, only 80 normal cubes per hour, which in the range, if you calculate compressor for it, it's in the range of half kilowatt or 5 kilo maximum of installed power for compressor. We have here another example in Cambridge, UK, where spent grains of 15 to 23 cubic per hour is conveyed, and we have here roughly a moisture content of 80%. The problems the existing expeller unit has was here to convey this long distance of 170 meters down the line, and that's where we come in here initially with our progressive cavity pump. And the interesting thing here is that we have done a full re-engineering of the existing solution. So you see here this large extension hopper, which was reused from the initial expeller unit, and we have only done here a re-engineering of this pre-existing screw conveyor, and that was then replaced by you see it here, progressive cavity pump. It looks quite similar. You have also here on the bottom of this hopper a screw, which is conveying the spent grain into our pump element, and here is a progressive cavity pump, which makes a difference really and enables us to bring plugs of 30 to 40 meter into the discharge pipework. Another reference that we have is Middleton distilleries, so Irish distillers, where we have a large capacity that must be conveyed spent grain, which is 50 tons per hour per pump, and the pump is here installed directly beneath a lauter ton, a large lauter ton. And also here we have replaced an initial expeller unit, so you see also here the air is in place right in the discharge pipework, and we can make use of it. And the piping was 80 meters of distance, so it goes out of this building and it converts here over the street and on top of this silo, so where it falls then into the silo to be stored. Interesting here, we have replaced a battery unit, and they really were struggling with changing moisture content and had really a problem on the out times, which were ranging up to 55 minutes, and we have arranged here to reduce it in the range of 60% and got out a constant time of only 22% in the end, and that was quite impressive and helps a lot to increase the productivity of this system. They have another process step where spent grain transportation is used. So we have here a pump that's handling 15-20 cubic meter per hour, where the sludge is coming from a lauter ton, and here also a centrifuge, and the piping is only 30 meter and a meter vertical. Let's come now to a promotion video that we have also recorded together with Irish distillers, because they were so satisfied about our solution, where we have replaced this screw conveyor of an expeller unit by our progressive cavity pumps.
We wanted to improve the productivity and our capacity as much as possible. The major problem was the transfer time for the draft from the lauter tons to our feeds recovery facility. It was just taking too long.
The main objectives and targets we were set for by Irish distillers was to be able to transfer the products in less than 50% of the initial conveying time within the existing pneumatic system.
So compared to the old system where we had a conveyor transferring into a pneumatic transfer system, now we had a positive effectively doing that transfer.
One of the big features about the SEEPEX progressive cavity pump is its ability to handle the variety of products and especially the ones which sit on the table and they don't move and they need assistance to get it moving. We had to use a combination of using pump technology and also pneumatic blowing to assist the product down the pipeline the total distance.
But reduced the time from about 55 minutes to do the transfer to about 22 minutes.
Another application that we've been successful in Irish distillers is supplying our new smart conveying technology.
Our facility runs 24/7. There's a huge demand for our products. Any downtime is pretty much not acceptable. The SET technology definitely helps. Instead of dismantling a whole lot of pipework, it's very easy to attend to a rotor or a stator, do an overhaul and get it back online quite quickly.
So our consultation starts at the initial pump sale, and then after we've delivered the pump, we then bring our consultation into the service and commissioning side to optimise their operating costs and to reduce the cost of ownership.
We did achieve 50% additional productivity. SEEPEX played a role, which was fantastic.
We're always seeking new emerging products that our customers want us to handle. These bring challenges to the company, lead to new innovations and application development.
And as I say, good partners become long-term partners.
So far to this installation at Irish Distillers and to a very satisfied customer that we have here in the Irish market on a distillery. Let's come to further references. So Williams Grant is also here distillery in UK, where we have fed into an energy plant, renewable energy plant, only 10 cubes per hour, but the distance is here around 90 meters and 15 vertical. And also here we have replaced and go directly beneath this existing extension hopper and put down here our progressive cavity pump and have reused the piping, including the air injections. So what we here enable with smart air injection is a full application range. So it's independent if you have a mesh tun or a lauter tun, if you have a mesh filter installed in your processes, or if you have some centrifuges, if you would like to feed into a silo, or you have an application where you have a silo discharge, so you would like to put the pump below the silo and further convey into the transportation on trucks, or if you would like to go for the further processing below a reception bunker and the trucks are here delivering the spent grains and you would like to transfer it for the further processing. All these applications can be used with SAI. And also we have here some applications where multi-source options are very interesting, so that you use one pump and one line for different process steps from mesh filter and mesh tun by the same equipment. That leads me also to the first validation study, so where it's also the case that we have here an extension hopper on our pump and also two process steps. So first one where the spent grains are transported and the second inlet here where spent hops get into the hopper. The capacities that are conveyed in St. Austell Brewery are around 4 tons per hour at a moisture content of around 80%. And here for the spent hops it's only 0.6 tons per hour. It goes 20 meter down the line and 10 meter vertical, because after this pumps here, it goes directly into the silo, what you see here in my bag. And the mixture of the spent grain and the spent hops is stored here inside and then further conveyed by a silo pump. So the discharge is also done by an SAI system. You see it here, we inject directly after the pump discharge the air into the system for the further processing, and then it goes down the line and is here put it down to the truck for further processing and unloading. And we have done here an upgrade, and we've compared the initial lean phase conveying situation with our SAI logics. So we have used here also very long plugs, and then we have manually done the injection of air in our SAI logics, and we're thereby able to reduce the air consumption of initially around 300 normal cubes down to below 50 normal cubes. So it's around 90% in reduction here of air consumption for the spent grain, and for the spent hops around 80% in air reduction that is consumed. The other way is here that we have looked a bit closer to the mash out times, and we come here initially from 28 minutes and go down here to 22 minutes, which is a reduction of 20% in mash out time by our SAI concept that was here applied. Another validation study is here in this larger southern German brewery. So you see here that we have two parallel lines where we have done an SEI logics and have used our concept in contrast to the pre-existing Pondorf system. And what we have achieved here is a reduction in energy efficiency, in energy, and also in the maintenance costs for the air components of around 12,000 euros per year. That could be saved by SEI in comparison to the Pondorf unit, and that's here really derived together with the brewmaster of this southern German brewery, which gave us a parameter on runtime scenario per year, brews per day, and about their energy costs and their air costs that they have for energy and maintenance. And if we accumulate those cost savings over 10 years of operation, this southern German brewery is able to save up to 120,000 euros in 10 years of operation, which was quite impressive. And that's done by this reduction of roughly 90% in air consumption that we have achieved here for this brewery. Let's summarize our application. So where we are more and more coming into is the application in brewing and distillery market, where we used SEI for the transportation of spent grains and spent hops. Also for the renewable energies plants, where it's used all for the malt vinegar production. We come usually for the wastewater industry with SEI, so we are in the market with this product since 2017. Until now we have more than 50 systems running in the market and nearly 99% in the Central Europe region. So UK, Germany, Nordic, Netherlands, France, and also Italy. The features that we derive here to you is a full package unit solution, so you receive all the pumps, air components, sensors, actuators. If you have already in place some air components, we can reuse it, and we will check on this. And these functional components are all integrated into our SEI software and our SEI logics. You receive from SEEPEX the full service package, so we clarify the application, we do a project coordination and also the system design for you, and a full commissioning of the system. And it's also here very important to note, we have full retrofit abilities. So if you have a pre-existing spent grain transportation systems, you have a pre-existing buffer hopper by your existing expeller unit, and you have already air injection in place, we only have to exchange the screw conveyor by our pump, extend it by our SEI logics, and it can run like an SEI system. And that gives you great benefits. To summarize here, you minimize your operational expenses because you have much less air and much less energy consumption. You increase your process efficiency because the mash out times are highly reduced. You have a very flexible operation point because if you have varying moisture content of the spent grains, the pump is independent of it, and also the dense phase conveying is nearly constant for change in moisture content. You increase your service life of your pipe because you have a conveying here that is using a lower velocity, and the medium transportation can range up to 1,000 meters of distance. Process availability is increased because it's very reliable, the systems, and you have your integrated cleaning for longer downtimes, and also the pipe routing is quite flexible. That's it from my side. Thank you for your attention. I hope I can reach a great interest for this new product. So if you have any questions, first you can also look to our webpage where we have more information, also some case studies on this product for the brewing and distilling industry. And if you would like to have more information or application that should be clarified, get in contact with me and SEEPEX, and we will help you on this. Thank you, have a good day, and stay healthy. Bye-bye.